So we're going to now write equations of circles. And yes, circles do have equations, just like lines have equations and parabolas have equations. And if you think about a circle, what's really neat about the circle is that you have a center point, and all the points around the circle are the same distance from the center of the circle. And that distance is called the radius. So this is neat how we're going to write this equation. And yep, it's an opportunity for more algebra, but even better is that we might have a guest appearance today. Oh, this is going to be really special. I can't wait. I am so excited for this. Alrighty. So we're going to use the distance formula, and we're going to write an equation that says some point P is 7 units from the point -3, 4. So just maybe like a sketch as to what that's going to look like. So here's the point -3, 4. Maybe it looks like that. And I want to go 7 units away from that. Well, in what direction? Well, I could go 7 units down and be like right here. I could be 7 units to the left. I could be 7 units up. I could be 7 units to the right. I could be 7 units over there, or down there, or down there, or down there. Do you see what we're making? Yeah, we're going to make a circle. So what's really interesting here is that the equation of a circle is a lot like the distance formula, which is a lot like the Pythagorean theorem. So this is pretty cool. So here we go. So here's my point there, and I'm going to put some point P out here. I don't know its coordinates. Call it x comma y. That's the point -3, 4. So I'm going to do a distance formula. I'm going to do that my distance, which is the square root of, let's see, if I do x subtract -3 squared, and then if I do y subtract 4 squared, and that's going to equal the distance, the length of the radius. But I know that length. I know that the length is 7. So I'm going to clean this up a little bit because I don't like square roots over there. So first of all, if I take the square root of both sides, I get 49 over here. And like we saw before, x subtract -3 is really x plus 3. And y subtract 4, we'll just leave it as y subtract 4. Guess what, ladies and gentlemen? This is the equation of your circle. Can you tell where the center of the circle is at -3, 4? Can you tell the -3 and the 4 in there? And can you tell that the radius is 7? Can you see that hidden in there? I bet you can. So let's play a little bit. Let's find the equation of this circle. And we're going to call it in its center radius form because, can you tell where the center is? The center's at -3, 4. And the radius is 7. So let's see if we can do the same thing here. If I want the center to be at -2, 4 and the radius is 3, I know it's going to look something like this. I know it's going to be like x minus -2 and y minus 4. And my radius, I remember I did the radius was 7 before and I wrote 49. So I got to do 3 squared. So maybe if I say the equation is like x plus 2 and y minus 4 and square those terms, and it equals 9. Okay. And maybe if I do the same thing for the other one, it's like x minus 0 squared, but we know what x minus 0 is. That's just x. And we'll do like y minus 6 squared equals 9 squared. Or do you want to make it like x squared plus y minus 6 squared equals 81. You want to square that? I like it. I like it a lot. Oh, look at that last one. Oh boy, it smells like a formula. Yeah, the center's at some point h comma k. So let's say it's like x minus that x value, x minus h, and y minus k. And it looks like we're squaring the radius. Doesn't it look a lot like a Pythagorean theorem? It sure does to me, man. It sure does. So some nice things here, some really nice things. So this is basically our formula for the equation of a circle that's in center radius form. We like that a lot. And like I said, it's a big Pythagorean theorem equation. All right, so let's play a little bit. This was our original one that we started with. I want to expand it out a little bit. I want to expand the binomials. So maybe you remember that when you squared a binomial, it was like writing the binomial twice and then doing the distributive property. I told you we could do some algebra here. So we get x squared plus 3x plus 3x plus 9, which is x squared plus 2 3x's. I should even do that. Let's make it, instead of 9, let's make it like 3 squared. So then we get x squared plus 6x plus 9. And I took my time to do that because I wanted you to see, do you remember maybe squaring a binomial? Where if I want to square, let's say like x plus something like y, what I do is I square the first term. Let's not do x plus y. That's not going to be ugly. Let's do something like, if it was like x plus 5 squared. I square the first term. And then check out what I do in here. I multiply the terms together, and I multiply it by 2. So I get 2 times 5x, which is 10x. And then I square the last term, 25. So it's a nice way to kind of do that without having to write it all out and do the distributive property. So when I do all that, I'm going to get x squared plus 6x plus 9. I'm going to do that for the x's. Let's do it for the y's now, and let's do our squaring. So we square the first term. We multiply the terms together, so negative 4 times y, but then we double it. And that gives us negative 8y. We double it because there's 2 of them. And then we square negative 4 and get positive 16. That's a really nice, convenient shortcut. If you remember anything about this lesson, remember that you can square a binomial very easily. Now, one thing that we like to do is we like to kind of group our terms together in a descending order. So I'm going to rewrite this as like x squared plus y squared, and then I'll put my x's and my y's. And then I'm going to combine some like terms and move it to the other side maybe. So we'll do like 9 plus 16, and that's 25. And if I subtract the 49 over, because typically what we'll do, we'll get my minus 24 on that. This is what's called standard form. And what we can really represent a lot of things in what's called the standard form. When you get to Algebra 2 next year, you'll do things like ellipses and hyperbolas. And even parabolas can be written in the standard form. So this is like the standard form of any type of curved shape, any type of line, anything we can graph really. So what happens if we start at standard form and work our way backwards? So we've got x squared plus y squared plus 6x plus 8y. Whoops, minus 8y, right? Oh, our guest just got here. Hello. Hello. Glad you made it. Was the traffic bad? It wasn't too bad. Okay, cool. Well, I'm glad you're here. You got your singing voice ready? I do. Fantastic. Oh, boy. So what I want to do, if I remember the last thing we did, was I kind of grouped my terms together. Let me kind of like ungroup my terms together. So I'm going to put my x squared over here. I'm going to put my y squared over here. I'm going to put my 6x over here. I'm going to put my negative 8y over here. And then I also put the 24 on the other side of the equation, so I'm going to add that back and get 24 over there. Is that 24, right? 25. Yeah, it is. It's good. Okay, just making sure. I thought my arithmetic was bad. Okay, so now here's my problem. I got to figure out what goes there. I got to figure out what goes there. I got a blank space, baby. And I'll write your name. Yeah, Taylor Swift just showed up. Hey, Taylor, it's so good to see you again. Oh, it's great to see you. Thanks for involving me in your math lessons. Oh, no problem at all. Anything I can do to help the future of America. Oh, you're so good. So let's talk about completing the square. You remember that? Oh, boy. So we take our 6x. And all I want to look at is the 6. I'm going to take the 6. I'm going to divide it by 2. And I'm going to square that number. And that's going to give me 9. And the 9 is what goes in my blank space, baby. And I'll write your name. I'm going to do the same thing for the y value. I'm going to take that -8. And I'm going to divide it by 2 and get -4 and square it and get 16. Positive 16 over there. Great. But hold on a second. In math, if you do something to one side, you better do it to the other side. So what I need to do is I need to add 9 to this side too and add 16 to that side too. So on the right side, I get 49. And on the left side, I can factor these expressions. This x squared plus 6x plus 9, it's a perfect square. That's why we complete the square, to write it as the square of x plus 3. And likewise, we'll write this as the square of y minus 4. And sure enough, this tells me that I got a circle whose center is at -3, 4, and whose radius is the square root of 49, which is 7. This is the question I'm going to give you to do on a test. Oh, Taylor, thanks. I got to catch a jet now. Flying to Boca. All right, see you later. Taylor Swift, everybody. So that's our process. Let's complete the square to find the center and the radius of this circle here. So we got to go through. We got to group our x's together. X squared plus 8x. Got a blank space, baby. And I'll write your name. I'll put my y squared and my minus 4y. I got another blank space there, baby. I'll write your name. I'm going to take this 16 and move it to the other side. And I'm going to put 2 more blank spaces and write your name over there. Okay, let's figure out what goes in each of those blank spaces. Let's complete the square. 8 divided by 2 is 4. Squared is 16. Put it there. Put it there. -4 divided by 2 squared is positive 4. Put a plus 4 there. Put a plus 4 there. On the right side, I got 36. On the left side, if I do some factoring, I got x plus 4, squaring that. And then I'll also square y minus 2. Pulling out my center. My center is at the point -4, 2. My radius is going to be the square root of 36, which is 6. Doing awesome. Doing awesome. So that's our completing the square to find their center and radius. Now I could be really evil and crazy and give you a problem like this one. And you're saying, no, it's not too bad. Numbers are pretty small. So let's work through this one. It's going to be the same idea. I'm going to set up my completing the square. I'm going to move my 5 to the other side. Got my blank spaces, baby. But check this out. When I complete the square now for x, I'm doing 7 divided by 2 squared. And you're like, oh no. Here's where decimals kill you. When you see the beauty of the fraction. If you're squaring 7 halves, you're really squaring 7 and getting 49, and squaring 2 and getting 4. And that's the number that you add to both sides. I know you're saying, wait a minute, I don't get it, I don't get it. Hold on. All I did was square 7 and square 2. And we're going to do the same thing with -5. We're going to divide it by 2 and square it. And we're going to get a 25 over 4. So I'm going to put a plus 25 over 4 and a plus 25 over 4. And you're like, whoa, hold on, this is crazy. No, it's not too bad yet. But now we got a factor. You're right. Did you notice anything back here? Did you notice that this 4 is half of 8? And this -2 is half of -4? And back here, this 3 is half of 6? How about that? So you want to know what goes in parentheses? Take half of 7. Take half of 5. Whoops. I know, but they're fractions. It's okay. But now I got to add the fractions together. Okay, watch this little trick. This is going to blow your mind. So you got to add fractions. The denominator's got to be the same. I want to write 5 as something with a denominator of 4. So 5 times 4 is 20. So now I'm going to add together 20 over 4, 49 over 4, and 25 over 4. Oh, I got to add those right. You're just adding the top numbers together. So 20 plus 49 is 69. 69 plus 25 is 89, 90, 91, 92, 94. So on this side, I get 94 over 4. And I know what you're saying. Oh, this is crazy looking. But remember, we're just looking for the center and radius. So the center is at negative 7 halves, 5 halves. And the radius is, take the square root of 94. Oh, look, the square root of 4 is 2. We're done. So that is how we complete the square when there's negatives in there. Enjoy.